In this part of the video, we are going to talk about the system architecture to get a better understanding of the technical workflow for MAITRI. For starters, we are going to talk about inputs and the three different types of inputs of audio, video, and physiological input and how we are retrieving its data. For audio input, we're going to use a crew cabin microphone arrays. For passive and ambient input, we're going to process this using Librosa or OpenCV for MFCC and pitch extraction to create our own vocal feature vectors. Whereas for video input, we're going to use onboard cameras for passive video input. And then we're again going to use OpenCV for face and landmark detection so that we can normalize our image and use it also for cropping. We're going to take input for physiological parameters using the variables and the biosensors that have been integrated onto the cabin cruise suits, and we are going to process this information using NumPy or Polars. Now we are going to talk about how we are going to process the specific models. For voice analysis, we're going to use TinyBERT. TinyBERT, as the name says, is a tinier version of the open Google's own architecture of BERT. The reason why we use TinyBERT over BERT is because of its tiny functionality and ability to be used over low-end devices. Then for facial expression recognition, we are going to use the convolutional neural network like AlexNet or VGG-16. The reason why I use an older model like VGG-16 is because of its ability to function on low-end devices or mobile devices. Then for physical well-being, we are going to use the one-dimensional CNN or isolation points so that we can detect all types of anomalies or trends in the of graphs and calculations of the sleep metrics and HRV or heart rate variability. Then once we have completed with model processing, we are going to use all this data for fusion and assessment for our very own dense neural network. Our dense neural network will then later be used to create a well-being index. This index will be our way to provide a therapeutical and physiological input for the ground to understand the current mental state of the astronaut. This DNA will be trained on ground using high performance GPUs, and we'll use PyTorch or TensorFlow for its framework, and we'll deploy it on the DAS low-end devices or the edge computing unit. Now, coming back to the well-being index. Our well-being index is the formulated and the completely processed, modally processed from all inputs to create our own metrics to have an insight, an easier insight using numbers on the mental health of our astronauts. Now, this will have a threshold value. If an astronaut has a value greater than the threshold value, then it suggests that there is an immense risk to his mental health and ground will be alerted. If the threshold value has not been reached, but it is still within cautionary parameters, then we are gonna run the AIA or adaptive interaction engine that is built in to MAITRI for an interactive session about well-being with MAITRI.